Hello. First, I would like to introduce you to Beppo. This is the kind road sweeper. Please be kind to him because he will be the one who cleans up after us.
It's from paper.
So it's all made from paper. It's very lightweight, and I'm doing paper sculptures since 2010. Strong woman. So I both do commissions for exhibitions or fairs, and also have a private sector where you can buy papercraft kits you build yourself. So all kinds of animals mostly, but I love the big ones. So it's always a challenge.
Wolfgang is a real bastler, and we can participate at his bastel technique. It is wonderful bastel technique, and I think we should all much more playful. We should work with our hands. And in his patterns, it's wonderful to make these sculptures. So go to him, ask him what he else has in petto, what drives him. Thank you, Wolfgang.
Thank you for the invitation.
Now, another wonderful panel. I'm very lucky that I have a good friend. It's Gabi Dreo. Gabi Dreo, Professor Dreo Rodosek. She will lead the next panel, another panel on quantum technology. I think it's so, as I said before, it's so important that we get to know, that we deep dive, that we learn about quantum. And Gabi, come on stage. Please introduce your panel. Gabi, you're one of the most renowned scientists. You're building up the code Cosmos. And tell us what you brought on quantum.
Thank you. Yeah, dear ladies and gentlemen, I have the honor to lead the new, or another panel about quantum computing. And I would just ask my panelists to come on stage. And quantum computing is promising. Yes, a big applause, please. Quantum computing is promising us to solve one or some of the biggest problems we have. So, about research, finance, healthcare, aerospace. Quantum machine may pose also serious challenges because there's a good also on our security. To break modern cryptography like asymmetric encryption. And some people are so saying that actually quantum computing, not AI, will define our future. The powerful new technology should be, of course, used for benefit humanity. Otherwise, we are missing the boat. And as every technology has implications to the society, it has also quantum computing. And so I have the pleasure to discuss this with a terrific panel where we will discuss what are where we are standing in quantum computing, what are the risks, and what is the blessing. And hopefully the blessing will succeed. So, may I start with Grazia Vittadini. She is Chief Technology Officer of Airbus. And Grazia, we see that actually quantum computing is promoting in research, but what are the industries? How is Airbus doing with quantum computing?
Yes, thank you very much, Gabi. So, you know, when I entered the aerospace industry, I'd always hear that aircraft are absolutely among the most complex products you can think of. 100,000 parts flying in close formation. Now, today, a couple of years later, let's take our A350, the most eco-efficient modern airliner flying out there. On top of these complexities we just discussed, put 250,000 sensors harvesting data to provide services to our customers via the Skywise platform. So complexity is still there, and it increases by the day. In addition, it's not just data, it's facing challenges which go well beyond pushing the boundaries of physics, which has always been the challenge in aviation. We have a projected growth which goes twice as fast as the pace of economy. We foresee in 15, 20 years to see 50,000 aircraft flying out there, which is a fantastic business case. But twice as many aircraft means twice as much emissions, noise, and traffic. Congestion is already a nightmare today. So just imagine double that to the amount of aircraft flying out there. So it is a problem of complex optimization where we have the privilege of having the leadership in the market. And this is a privilege which comes with great responsibility. We will not enable this type of growth without a commitment to sustainability. And that's why we're committing to being the first out there flying with a zero-emission aircraft, based on revolutionary technologies, which may be around propulsion, new propulsion types, electric, hybrid, put hydrogen in the equation, new fuels, synthetic fuels, biofuels, new shapes. When you leave traditional propulsion and go into, for instance, electric or hybrid electric, you are free to distribute it as you want. So new revolutionary structures, being more and more aerodynamic, more and more laminar, as we say it, so less drag, more efficiency, less consumption, less weight, new materials, eco-materials, recyclable materials, looking at the end-to-end life cycle assessment of our products, who will be more and more autonomous, because autonomy is also a key for efficiency. We're demonstrating, we just launched a demonstrator, we will be flying like migratory birds do in V formation, surfing each other's vortexes. This can reduce emissions by up to 10%. So many, many different technologies, all to be developed in a concurrent and coherent way to be the first out there with a zero-emission aircraft. Now, very complex optimization problem where we're just basically reaching the limit of how many transistors we can pack on a chip in order to have the computing power we need in real time to enable all this. So we need a quantum leap in computing. We need quantum.
Very good, okay. Well, let's ask Heike. Heike, she is an IBM fellow. What's of the most superior roles in IBM at IBM Research Ruschlikon? And you're also head of science technology at IBM. Google claimed, I have to ask, to have reached quantum supremacy, which means that they have demonstrated that, for example, a programmable quantum device can solve a problem that a classical computer cannot. So the question is, has Google said, hello, quantum world?
So quantum is a really dynamic field, and I had the pleasure to be here last year to talk about quantum. And at that time, they had a processor of 20 qubits, and within 1 year, now 2 companies have announced a chip and demonstrated the chip with 53 qubits last October, IBM and Google. And so there's really a lot of dynamics, a lot of activity, and a lot of breakthroughs which are happening. And quantum supremacy is a term which kind of claims that the quantum computer can do something a classical computer cannot do. And that's to some extent difficult, very difficult to do. And Google has chosen kind of a very specific toy problem, which is tailored towards the specifics of the quantum computer. And have done, I don't want to go into detail, but they have done this type of specific problem in about 3.5 minutes. And then it's about, okay, how long does a classical computer need for this, right? And if you do it in a very straightforward way, then the prediction was that it may take 10,000 years. But if you do it in a smarter way, on the highest, on the biggest supercomputer which exists today in the world, then it takes about 2 to 3 days. So I wouldn't say it's not really yet achieved, and we should be careful because we don't really want to create a hype that we kind of claim we can do today everything and we have reached supremacy. So there is really a lot of progress, and as I said, the qubit chips today, they have 53 qubits, and we are bringing also the quantum computers from the physics lab into the data center. So last September, we have opened in Poughkeepsie, New York, the first IBM Quantum Computing Data Center, where we have 15 quantum computers which are accessible through the cloud. So they're really accessible to our partners. And so we are looking into the kind of showing a quantum advantage. Because that's the thing what the industry is looking for, what you already said, right? You want to solve your complex optimization problems. It is only one example for these exponential problems which can not be solved by classical computers. And so we really wanted to we are working on those problems which create value to industry. And these are optimization problems, these are problems into developing new materials, because materials is an issue actually in every industry. And today, it typically takes about 20 years until a new material is fully developed from the research lab into a product. And so to speed this up by getting faster, using the calculations quantum computers can do, by using the laws of quantum physics for materials optimization. This goes back also into climate again. So there's a lot of these things which quantum computers can do, but these are also very special problems they are working on. And for us, it's really important to demonstrate the value for the industry.
The Research Institute code, which I'm heading, is one of the 9 IBM Q hubs worldwide, so I'm glad to hear that we had made the right decision. Helmut, you are head of Center for Digital Safety and Security at the Austrian Institute of Technology, and you are very involved in the European side initiative promoting quantum computing. And we see that Europe has a long tradition, in fact, financing research in quantum computing since 1998 already, and putting now in the quantum technology flagship over 1 billion of funding and the vision build a quantum web. My question is, to be more provocative, is Europe financing research and others are making money because Europe has no quantum computer?
To answer this question, let me first share with you a good and a bad message on discussion. First of all, just to summarize what you just summarized and what we have to understand, it is a complicated technology. So we need a lot of experts, experience, highly skilled people from the physical, on the physical level, and the physicians, but also from the electronic side. So we need the experts. And that's the technology. And also in the morning, we already in other fields were discussing about innovation. So at the end, we need products and we need added value for customers and markets. So to create now and to build the next level, that these building blocks with our scientists are understanding, for them perhaps it's already solved. So I would say for some of my scientists who know they have already 10 years ago told me it's already solved in principle. But the next step to build a product needs much more. And here, that's for me the good message is, first of all, the good message is we have an enormous tradition in Europe and we have many universities and we have, from my point of view, a very good, in all our countries in the European Union, a very good basis of this expertise. So I think we understand it and we know it. And I want to prove it with one sentence which was posted last year in summer in the Washington Post. So there was an article about quantum technology in Europe and US. And mainly the summary, the mood of the article was, China is ahead of the Americans. And all what they know, they have from Europe. So that's amazing. So the basic science, the expertise, we have it in our country. So that's the good message. We have it. We can sit together and we understand it. We have the people. And next level then, how to build now a product, there is no need much more. We need an ecosystem. We need technology. We need products. First generation products, we need a kind of markets. So we can wait now, like in a free market, that it happens, or we can try to stimulate it. So that's the next level of funding or supporting or enabling applied research, first market experiments. And here, from my point of view, is observing Europe over the last years, there is some room for improvement. Europe now, European Commission makes a strong effort now to invest more. So, for example, we are running several European projects. AIT is in the mandate of operating several European projects, where not only research is funded, but also the funding of startups, the generation of technology for big industries, the cooperation among European member states, which is very critical because there are so many still open issues to be solved, so cooperation is very essential. And that's what we have to focus on. Understanding that in our small markets, we will not be able to be at the end competitive on a global scale, so we have to cooperate. We have to bring the basic scientists in close cooperation with the technicians, the engineers, the industry in the market. And if the market is not yet there, the technology is too expensive and that added value is not yet seeable at the moment, also the public community, the government side has to play a role as an innovative supporter, an innovative investor into our markets. Otherwise, we will not be successful in a global market competition.
Or do you think that Europe will wake up and do such, building such ecosystem, cybersecurity ecosystem, to be in the lead in quantum computing and also quantum computers, products, services, programming languages, standardization?
Just for the quantum computers, just to refer to one project, there is also another term which has to be understood, the quantum communication. So there is the idea, and we are already doing it, and we know how to do it. There are still technical problems, but we are working in this direction to build a network based on optical infrastructure, based on satellites, that we can connect individual quantum computers, for example, in the individual places all over Europe. So if we are able to connect the famous capabilities of individual quantum computers, even with others, and we understand how this communication of this strange quantum states can happen, we can build an enormous, powerful infrastructure and technology. But of course, we have to have vision for it, we have to have the expertise, and we have to do it, not just sitting in the labs and waiting till somebody else is implementing it.
Very good. Coming to Jan, you are co-founder and CEO of IQM Quantum Computers. Your company is spin-off from Aalto University and VTT Technical Research Center of Finland. So you are developing also quantum processors and for large-scale and fault-tolerant quantum computing. Are you a competitor to IBM? Should Europe invest in your company?
Well, is this working? Yeah. So we are a spin-out, as you said, with 30 people and based in Helsinki. And IBM, of course, is, I guess, in global scales, one of the companies with the largest budgets for quantum. So it's hard for us to compete on the whole scale. However, I think what we have in Europe on the different aspects of quantum computing, so there are different hardware layers, there are different enabling technologies around this. We have in all of these fields, I think, very leading efforts both on the university but also in the startup scene. So for example, also in Finland, we have a company called Bluefors, which is the market leader for cryogenics. In Zurich, we have a company building electronics, Zurich Instruments, and others. So I think what we need to do is we need to bring this all together, and then we are really competitive. This is one thing. The other thing, of course, at the moment, and you mentioned this, there's no market yet, right? So quantum computing is still a little bit before it actually something it's being commercialized. However, what also needs to be done is there needs to be a education of people in the society so they understand what quantum means, to take away maybe some fear also. And for example, I think IBM is doing a great job there in educating people by putting machines online so that everyone can get a hands-on experience. So I think the question is not so much are we a competitor or not, but it's more how can we actually create in Europe a situation where we could be a competitor and develop in this direction.
Can I maybe add to this? Because I mean, we are working really also creating a lot of partners, right? Because it's important that we create the ecosystem of the technology. It's a completely different type of computing. It looks completely different than a classical computer, and it needs different stuff than a classical computer. And therefore, there's a complete ecosystem. We are working together. We are working also together with this, startups in Austria, like AQT, and also with software companies, with the ecosystem of Zurich Instruments, which you mentioned. And for us, from the beginning, it was really when we had the 5-qubit chip in 2016 in May, we already brought in online to actually create this ecosystem and to involve universities, to involve researchers, to provide the chip, the ability also for theorists to access the chip, to think about new algorithms, because otherwise we are not developing these things into the way that we can accelerate it together. So it's about learning, it's about accelerating the research to bring the value very quickly into the industry around the world. And so the education is actually a very strong part. So we have, and I actually have been leading the team in the US when we started this, and suddenly we were about, okay, we have to create a community. Oh, I need people to take care about the community, right? Out of research, we have actually started to drive this and brought then also the chip online. And I actually met a researcher from Basel who very early on actually took opportunity from of having the access. And it was interesting to see him so being passionate and excited about now having the capability of testing his theoretical thoughts onto a real chip and getting the result back and seeing what the true result is and optimizing it. So it was really fascinating to see him being super excited about this possibility, because otherwise, before he had to go to experimentalist, it was a very complex system. It took forever to set up the system, right, and to make perhaps one experiment on chance.
Yeah.
And so now there's a huge capability which everyone can use to further develop the field together.
Yeah, we are doing this also in the Q Hub, so accelerating and providing research and education.
So right now, actually last week at CES, we have more than 100 big partners and hubs, and you are one here in Munich, and also with the collaboration with Fraunhofer, we bring also a quantum computer to Germany, so it will be actually the first one outside of the US, so I think that's really, you know, as a European, originally coming from Germany, working in Switzerland for a US company, I'm really excited about the international collaboration, which I think we have to bring in much further, in particular as scientists, as engineers, as industries, against certain, you know...
Yeah, okay.
Yeah, exactly. So,
Lena, you are CEO of Initiative 21 and addressing especially the impact of technology to society. You're very active discussing ethical issues of AI and so on. What do you think quantum computing will have, what impact will quantum computing have on the society, especially if we see sentences like quantum finance, quantum economics, quantum diplomacy, quantum ethics, whatever there is and stuff?
Well, if you look at the discussion about digitalization, we see a lot of ethic questions come up. And, well, there is an ethical dimension to everything that humans do. So since we are humans sitting here on the panel talking about quantum computing, yes, there's also an ethical dimension to quantum computing. One thing with digitalization is that it offers us new fields of action. I mean, we have new options for automation. We have new options when it comes to datafication, as in data collection, data analyzation, and all those things give us new ways to interact. We especially see this development when it comes to AI and machine learning because data becomes just so powerful. And this raises ethical questions. We've seen a great talk from Joy this morning on bias in AI. So that, of course, would be a negative question and a development we would have to pay attention to. On the other hand, if we see all the possible new things that AI and machine learning can do, wouldn't it be highly unethical not to tap into this? And this brings me to quantum. When I listen to all the possibilities that we could achieve with quantum computing, I think we also have to talk about, wouldn't it be unethical not to tap into this and to do the research and to fund also all the work in that field? Of course, quantum computing is a very complicated matter when it comes to society, so there's not really an understanding yet, which also brings us to the task to educate, to get the right workforce into the country, to educate people with digital skills. So that of course, is going to be one big thing to do. And the other will be that quantum computing basically accelerates all other technology trends. So if I look into your research, for example, I see, of course, you can do different machine learning techniques if you combine it with quantum. So we're going to see a lot more changes, and society will be faced with these changes, and we're going to have to ask the questions, is it a good development, or is it something that we as humans, since we can shape it, want to shape it in a good way?
Helmut? Yes. Big applause.
Well, I would like to add on this what you just asked, and you summarized more or less, just that there's no misunderstanding, or just to be also provocative on my side. I think this quantum technology, to be more general, is not a field where I believe one company can keep it secret and develop it, and then sometime it has it, and now he has an advantage. I think just to recover what it is, I mean, we already have the existing transistors on computers which are based on the also quantum technology. All these technologies, the behavior of transistors and electronic components basically are working on the statistics of a huge amount of quantums, of parts, of particles. Now we're going to understand the behavior of individual particles. That's amazing. It will change everything. It will change the way how we build electronics. It's already doing it. And just in terms of pace of technology, if you compare what we have done, 10 years ago when I started at AIT, we had a big rack demonstrating, already working, being able to manage individual quantum states. So it was there, it's working. Now, in some of these European projects, we're already in status today to bring them on a chip level. So we're bringing them what was 10 years ago in a big industrial computer rack, now on a chip level. Now we can build it in sensors, we can distribute it. It will change the way how we build electronics in the future. So it's a huge change of the whole industry. At the same time, we have a new behavior of this quantum states. So we have to learn how to write algorithms, how to write new code. There are not too many experts so far in our country, so we need the training, we need the education, and if this understanding of new way of problem solving from the mathematical side, from the computer science side, having then the technology, we also change the application world. So exactly this field means we need to establish competences in our countries, but then we need much more than any other fields, a lot of cooperation on technology level, but also on application level.
Yeah, I just wanted to add to this because I wanted to also mention that quantum computing will not replace the conventional computing, because quantum computing is really to solve special problems which you cannot solve with a classical computer and will never be able to solve with a classical computer. And these are, for example, as mentioned, these complex optimization problems where the complexity of the problem exponentially increases the more parameters you have. And they cannot be solved with the classical computers. So these are supposed to be solved then in the future with those quantum computers. Then AI workloads, for example, we discussed cognitive manufacturing before, where you have a lot of big data and you want to create patterns and things like that. They will be solved with certain accelerators, other machines, which are specifically purposed and made for these type of workloads. And there will be still kind of for text writing, in the text editing, conventional computers will be used. So you will have all these three types of computers working seamlessly together. And this is actually also what companies have to provide in the end, because you as a user, you don't want to worry about where you want to have your problem solved. You just want to get it solved as quickly as possible, as cheap as possible, with the lowest energy consumption possible. And I think that's what we are working on.
Absolutely agree. Maybe just to ask one problem, of course, we have with quantum computers. They can break, if they, somewhere in the future, they can break asymmetric encryption. And our private key infrastructure, the data we are encrypting today, are based on these algorithms. So industry, for example, are really analyzing and developing post-quantum crypto. What is Airbus doing?
Yes, we already have some very interesting, at Airbus, some use cases of quantum computing, but also quantum communications and quantum sensing. Well, for computing, we all know the case of the traveling salesman, right? So one salesman, one trip, 15 cities to connect. Well, that makes 45 billion possible routes to connect the cities. So just imagine 50,000 aircraft out there, 100 megacities projected in 20 years. Just think, more flights per day, different altitudes, different weather conditions, what type of complex optimization problem that is, okay? So this is just one of the cases where indeed we went into exploring the capabilities of quantum computing, in terms of finding that perfect handshake between high-performance computing and quantum computing, because that, I believe, will be the route we'll need to travel along in order to really exploit, at best, the potential of quantum. Quantum communications, indeed, thanks to Heisenberg's uncertainty principle, we know that we cannot observe a photon without perturbating it, right? And quantum encryption is indeed the only possible way to protect from passive interception. So you could not have anybody eavesdropping into your communications without perturbating the message and potentially destroying it. So it's absolutely a very safe way. We're exploring together in the QDOS, in our QDOS joint project, for instance, how to encrypt comms and command and control chain when it comes to unmanned vehicles, typically drones. How do we protect that? And the potential of quantum communication, not only for us as an industry, but for Europe, is really infinite. Sensing as well, more atomic, more accurate atomic clocks will enable us more specific and precise guidance, navigation, and control systems. Let me just conclude with a flashback. 1 year ago, from this very stage, we launched the first Airbus Quantum Computing Challenge. 1 year after, we are wrapping it up, having the results assessed by a jury of experts. What do? We put out there 5 typical problems we face when developing an aircraft, convinced that we'd have a handful of replies. Now, we had more than 1,000 people interested to follow the progress of this challenge, and 38 submissions out of more than 70 countries. It's amazing. We're just at the beginning of what we can achieve with quantum, just as we were back in 1903, not because I was around, but that's when the Wright brothers had the first motorized manned flight. The potential of aviation was far from being exploited. It was not always clear, what are we going to use this wonderful aircraft for? And I really see the parallel. We're just at the beginning of it.
So I would say we are more or less at the end of the session, but I think European cybersecurity building ecosystems is similar also for building ecosystems for quantum computing. And I would just give a small and quick answer. The question of the panel was blessing or risk, or what we need to do that we have the blessing out of quantum computing and eliminating risk. So from the society, what needs the society perspective needs to add?
I think it's definitely going to be a blessing because there's so many chances to find solutions for problems that are actually there. But it also comes with a great responsibility to shape it in a good way for society.
What? Götz?
Yeah, so I think I totally agree, and I think it's also for Europe, it's a big chance now because still quantum is quite some time until we have something that really, really works, and I think Europe is doing very well. So I think if we all now do a common effort, I think it's a great chance for us to go back and be one of the technology leaders globally.
Very briefly, I mean, especially in this digital area, we are prominently discussing OS is ahead of us, all the digital data stuff is already happening to us. On the other side, we have China with their powerful, we collect all the data. So the AI side is already again, sometimes I believe in Europe, we say, what should we do? We have already lost this game. I think we should have much more confidence in our capabilities, and exactly this new technology, quantum leap at the end, give us the basis to come back on the scene, and we can be successful if we build on our confidence that we are able to build it. We can do it, but we should do it.
Mm-hmm.
Yeah, so as a passionate researcher working on things which are always like 10 to 15 years ahead, right? It's quantum computing. When we started with this in 1982, the physics community, I came in a bit later, it was so far away, right? And now being in this era where it's so dynamic and we are close to solving these exponential problems which computers cannot do by these quantum computers is really super exciting. And I think a lot of collaboration is needed worldwide in order to make these things happen and make it available to everyone. And it's for a researcher, having worked also on other areas like organic materials for displays, you always have to be aware of the risks of things which you are doing or of materials you are developing and you are using. I think this responsibility every scientist and researcher has, and also in collaboration with the engineers, with the companies, and also with the governments to then make regulations, and also with the journalists and everyone to talk in an understandable and true way about it.
Mm-hmm. Okay. So quantum technologies are, for me, definitely a blessing. It will be a matter of making sure that we continue developing them and developing the applications in a decentralized and collaborative mode. Not creating silos in industry, pillaging resources from academia, from institutes to create quantum departments. It's more really a matter of creating these networks, harnessing on knowledge, on expertise, wherever it may be. Open innovation is definitely a fantastic vehicle to do that. And again, collaboration in a decentralized way, and the potential is infinite.
So this is a very nice concluding word: building ecosystems, building cooperation, making the best out of it, minimizing risk, and develop quantum-resistant applications will be, so as we've seen it from the 1972, as we started programming. I think we are also at this stage where we'll boost the development of applications. I hopefully also on the European level will be on the same range as the others. And stay tuned for the next year, because I think the technology is developing so fast that we will have to report the next year a really increase in development what we have achieved. So thank you once again for my panelists. A big